So our next example is going to demonstrate the use of memory on the stack allocated for local variables, and then using EBP, the base pointer, to access these variables. So in high-level languages like C, we have local variables which we can declare only within a procedure. So just any demonstration that we've used, this is an example of local variables. Variable and this local variable as well as this local variable. All of these local variables are allocated in the stack memory. So local variables usually constructed on the stack, and in the assembly language procedure we can define and use our own local variables in a very similar manner. So what we do is, of course, we're going to continue register EBP as a base pointer and access local variables using the negative offsets or displacements from the memory pointed by EBP to locate our local variables. So let's take a look at this example. So we have a call into procedure name subtract3. So what this procedure does, it gets one argument on the stack from the caller. Okay, and of course what we do here, we push EBP, move EBP ESP, the typical entry and construction of the stack frame. So now the base pointer is all set to locate the first value in memory, and this is actually where the manipulation is happening. So for instance, if we push this value 10, so once again let's envision what happens with our stack. So this is our stack area. So first we push the value 10 into the stack, and this is our procedure parameter. Then we make a call, so we have return address on the stack. Then we preserve EBP. As we make a call, we start preserving the EBP. So now we get EBP saved on the stack, and stack pointer is now pointing to register EBP, and we set EBP equal ESP. So essentially at this stage, register EBP right here is pointing to its own old copy, whatever its old value was right here. So then we subtract 4 bytes from position of ESP, and this provides us, by the way, this is a typo again. This is probably adopted from the version for 16-bit, so this should actually say 4. This is incorrect. This is a typo right here. This number should be 4. Okay, so we just reserve space and we move ESP, right? So we push we subtract 4 bytes from ESP. So we don't push anything onto the stack, we just adjust the stack pointer. So our stack pointer right here is going to be adjusted, and basically it provides space for one more integer, right? So let's just say that this integer right now is just a question mark. We don't know what this is. We just adjusted ESP pointer in case we need to save registers or whatever we want to do. So we just adjusted ESP to this position, right? So right now ESP pointing here, and this is the top of the stack. So then we say let's assume that this is our now local variable, because we officially sort of reserve space for it on the stack. And we now saving their value 6. Okay, so this EBP minus 4, of course EBP minus 4, remember these are low addresses and these are high addresses. So this is the way the stack is organized. So if we subtract from EBP, we're moving in this direction. EBP minus 4 should give us the same access. So now this instruction EBP minus 4 address should save immediate value 6 right here on the stack. So now our local variable, this integer, basically 32-bit integer, is initialized with value 6. So then we move, so this is an example of loading this value into register EAX. So we take 6 and we basically set EAX equals 6, right, as a result of, again, using access to the local variable using the base pointer register. Then this next instruction subtracts from EBP plus 8, right? So EBP plus 8, this is EBP plus 4, return address, and EBP plus 8 is our parameter 10 that we passed on the stack. So this is procedure parameter, which is also very much like a local variable. So the positive offset from EBP gives us access to this, and we say let's subtract 6 from EBP plus 8. So 10 minus 6 equals 4. So this value is updated with this memory location on the stack is updated with 4. So 10 becomes 4 as a result of this subtraction, and then we take it from there and load into register EAX. Of course, EAX should become 4 as a result of basically copying this into EAX from this EBP plus 8 location on the stack. Then this is the way to clear local variables. Basically bring stack pointer back to EBP, right? So just bring whatever. We could have allocated space for many more local variables right here. And we just want to drop this whole thing back to where it was before we allocated space for all of these local variables. So what we do is just simply set ESP equal EBP, and then EBP becomes top of the stack. We pop EBP, so we restore EBP back to the way it was, and now of course this pop EBP brings a stack pointer back to the return address, and now we're perfectly ready to return. And so we use this return address to return. So return brings us back to this instruction right here. And of course, return also increments stack pointer by 4 bytes, the size of the return address. So we're now back here. Okay, so we're now facing, like, the top of the stack becomes this push, the copy of EAX. And again, this is, I apologize, this is a typo. In these examples, this should say ESP, not SP. SP would be appropriate for 16-bit mode. This is 32-bit mode. So we say add ESP4, right? So this removes this, throws away this value from the stack, which was pushed over here. So in a way, this push and this add, they balance each other out, right, in terms of the position of the stack pointer, because the stack pointer here was pointing at the beginning right here, and at this stage it's again back to pointing to the same thing, and now we can begin to return from the main procedure as well. Okay, in summary, this initial set of instructions, push EBP, move EBP, ESP, establishes our or begins to construct our procedure stack frame or activation record. That's been called it's been called the activation record in Unix environment. Same thing. So what is happening here is that we have our stack memory, and of course the last thing here appears to be push EBP. So EBP is the last thing that's saved on the stack, And then, so basically both EBP and ESP are pointing to this location in stack memory. We could have already pushed some parameters here, so there could be some, of course, the next thing, we assume that the next thing on the stack is return address, right here. Okay, so this is the next element on the stack. And here could be some input parameters for the procedure, right? So the parameters that were pushed earlier on the stack. And then we can use this instruction to subtract something from ESP to allocate space, to reserve space for some local variables, right? So we could just allocate space for some local variables, which of course will be uninitialized. So I just use question mark. We don't know what is in this memory, but this is already initialized. So at this stage, when we do subtract, then ESP is pointing to new location. So then the negative offsets from EBP in this direction, right? So EBP -4, so negative displacement right here gives us access to our local variables, right? So it's something that we organize as local variables on the stack. And likewise, positive displacements, positive offsets from location of EBP will be access to our input arguments. Basically, they're exactly like local variables, but they just were created there by the caller, not by the procedure itself. Procedure just assumes that this is the location of input arguments that were passed by the caller to the procedure. Again, these are low addresses in memory, and these are high addresses in memory. That's why when we make our adjustments, we need to remember where to subtract and where to add, because that's how we need to move addresses, especially the stack pointer. Again, this is ESP, right? So this is our demonstration of the organization of the stack frame. So altogether, this is what is the stack frame. So the stack frame is essentially this area of memory accessible through register EBP, which sits right in the middle of it, together next to return address, and allows us to access things that are really truly local to our procedure. Because essentially, procedure arguments, first of all, local variables will be thrown away, then EBP will be thrown away, then we return, and the return address will be thrown away, and then the local parameters will be also thrown away from the stack. So all of this memory will be deconstructed after procedure returns. So anyway, but this is the idea of the stack frame that contains local variables, copy of EBP, return address, and a set of procedure input parameters.